All right, welcome to day 80. Today, we're going to talk about a really crucial process, fine-tuning. This is how we turn a generalist AI into a true specialist.
So you've probably noticed this, right? We have these huge language models that can explain quantum physics, but then you ask one to do a seemingly simple job, like categorize your company's support tickets, and it just falls flat. How can something so broadly intelligent be so specifically clumsy?
Well, that gap between general knowledge and specialized skill is exactly what we're going to close today. By the end of this, you'll understand how to transform that generalist AI into a focused, high-performing expert for your specific needs.
The core idea here is surprisingly intuitive. You can really just think of it as teaching a seasoned expert some very specific new tricks.
Let's use a mental model. Picture a world-class chef. This person is trained for years, they know thousands of recipes, and they understand food chemistry on a deep level. That chef, that's our pre-trained language model. It has a vast, general understanding of its domain, in this case, human language. Now, what if you want this amazing chef to perfectly recreate your grandmother's secret pasta sauce? You're not going to teach them how to boil water, right? Of course not. You just give them the recipe. That recipe is your small, task-specific dataset. The chef studies it, making a few small adjustments to their technique. This is the process of updating the model's internal parameters. You can think of them as millions of tiny knobs the model uses to make decisions. Pretty soon, they've absolutely mastered the recipe. They've become a specialist. But crucially, they haven't forgotten how to make everything else. That's fine-tuning. So, to put a formal definition on it, fine-tuning is simply the process of taking a pre-trained model and continuing its training, but this time on a much smaller, domain-specific dataset. The crucial point here is that we're not training from scratch. It's what we call transfer learning. We're taking that massive head start from the pre-trained model and just giving it a much more focused curriculum. That's what makes it so incredibly efficient.
So how does this continued training actually work under the hood? Well, there are two main paths you can take to create that specialist.
The first path is full fine-tuning. This is the brute force approach. You retrain every single parameter in the model on the new data. It works, but it's computationally expensive, and it risks something called catastrophic forgetting, where the model gets so good at the new task, say analyzing legal documents, that it actually starts to forget how to write a simple poem. The second, more modern path is parameter-efficient fine-tuning, or PEFT. This is the surgical approach. The core idea behind PEFT is to be smart about it. Instead of changing everything, you freeze the vast majority of the original model's parameters. This preserves all that valuable general knowledge. Then you add a small number of new trainable parameters, and you only update those. A popular PEFT technique that does this is called LoRA, which stands for low-rank adaptation. And this number really shows the efficiency gain. With PEFT, you're often training less than 5%, and sometimes even less than 1% of the total model parameters. This dramatically lowers your compute costs, speeds up training, and makes it way easier to manage multiple specialized models, since you only need to store that tiny set of new parameters for each task, not a full copy of the entire model.
Okay, that's the theory. So where does fine-tuning actually show up in real-world systems?
The short answer is anywhere you need deep expertise. A general model is fine-tuned on medical text to summarize patient records, understanding jargon it never saw online. In customer support, a model learns a specific product catalog to generate helpful replies. In finance, it analyzes market sentiment from reports. In all of these cases, fine-tuning provides that final mile of specialization that makes the model truly useful.
And this isn't just for internal company projects. When major labs release open-source models, they often provide fine-tuned versions. For instance, Meta's Llama base model is our generalist chef. But they also release variants like Llama Chat and Code Llama, which have been specialized for conversation and code generation using this exact process.
So let's wrap this up with the single most important idea to remember.
If you take away just one thing, make it this. Fine-tuning is the bridge between a model that knows a lot and a model that can do something specific and valuable with that knowledge. It's what turns a fascinating piece of technology into a practical tool. By understanding fine-tuning, you understand how we unlock the real-world potential of large language models for almost any problem you can think of.